As you might have noticed, there are currently no validations in our sample project. We can register a new student with any name, email, or address. And we can also pass any value as the student ID when working with the existing students. For example, let's start the application and see what happens if I try to edit personal information of a non-existent student, a student with ID 4. The application throws a null reference exception because such a student doesn't exist in our database. This exception is then gets into our global exception handler that converts it into an internal server error, a 500 response. Note that while this behavior may look acceptable at first, after all, the application is returning an error here, it's really not. First of all, this message doesn't tell the clients much about what they did to cause that error. The second issue here is that all validation errors should return a 400 response, not 500. 500 responses are reserved for unexpected errors in your application, such as bugs, network connectivity failures, and so on. Validation errors are by definition expected. That's because any external input to your system may contain errors. You should not rely on clients to properly validate that input before sending it. Therefore, you should expect validation errors to happen. We will talk more about 400 and 500 responses in later modules. You can also watch my course about functional principles in C#, where I talked in depth about expected versus unexpected errors. This issue of not returning a proper error message is not the only one here. It's also not the biggest issue with the lack of validation. It's immediately visible and doesn't cause much trouble outside of the inconvenience of not knowing what caused the error. Another issue here is that we can also create students with incorrect data. There is nothing stopping the clients from doing so. For example, when we register a student, we pass a name, an email, and a physical address as arguments. Because there is no validation, we can specify an invalid email or empty name, and this incorrect data will be successfully persisted in the database, where it will require much more effort to deal with. And so all this input should be validated. Such a validation takes a lot of work. For example, we need to check if the name is null, and if it is, return a relevant error to the client. In fact, not only do we need to check if the name is null, we also need to reject empty strings and white spaces. We also need to validate the length of the name field, because our database has limitations on how many characters we can store in the corresponding column. The same goes for the email field. We also need to ensure it's not empty and that its length is within limits, and that limit could be different from that of the name field. On top of that, we have to do a regular expression check to make sure the email address conforms to some basic standards. Most likely, there should also be a check for email uniqueness, so that two students cannot register with the same email address. Moreover, the request itself can be null too, so we need to check for that as well. Otherwise, any reference to a property of that request will throw a null reference exception. And of course, we need to put this check before everything else. Same goes for the third field, address. It should also be not empty and not too long in size. Notice how the validation code has become several times larger than the actual business logic code. And that's with just 3 simple fields and primitive validation requirements, which are returning a string as the error message. In most projects, you cannot return just a string. You need to operate error codes in addition to these error messages. Moreover, you often need to return not just the first error, but a list of all errors that took place during the validation process. This will increase the size of our already large validation code even further. The same validations should be done in the edit personal info method because it also accepts the name and the address of the student. In addition to these validations, We also need to check that the student the client wants to edit actually exists in the database. In the enrollment method, aside from the student existence check, we also need to make sure the course name is correct and that the grade is parsed correctly as well. And don't forget that there are business rules in the enrollment method of the student class. These rules tell us that a student cannot enroll in more than 2 courses, and that they cannot enroll into one course twice. And we need to validate those business rules somehow in our controller as well. At this point, it's clear that such manual, naive approach to input validation leads to a lot of boilerplate code that clutters the project and ultimately hinders its maintainability. This is where the Fluent Validation Library comes into play. In the next module, we will start exploring its functionality and we'll see how it helps us extract all the validation rules out of controllers and make those rules much easier to understand and reason about. In this module, we discussed the structure of this course, reviewed the sample project, and briefly touched upon the topic of validation. Validation, also known as input validation, is the process of ensuring that data that enters your system from external world is correct. We will discuss the theory behind this concept in more detail in later modules, as well as validating data that is already present in the system. We also briefly discussed the difference between 400 and 500 response codes. The 400 response code should be used for validation errors, the 500 response code for internal server errors. The difference between them is that the former is caused by the client, while the latter by the server itself. This is another concept that we'll discuss in more detail when we'll be talking about the theory behind validation. In the next module, we'll start exploring the Fluent Validation Library. We will introduce validation checks in a more appropriate way, not the manual, naive way we did them in this module.